Hey, welcome back to chapter 6. We are going to start writing formulas for ionic compounds today. So in the first video, I introduced you to chemical compounds. In the second video, I introduced you to how to predict what sorts of ions these different atoms form. Today, we're going to take two atoms and we're going to put them together into an ionic formula. So, ionic formulas today. In the last video, I left you with a graphic that looks something like this. So, lots and lots of juicy information on this graphic. First, group 1, 2, 3, 4, 5, 6, 7, 8. That's how we predict valence electrons. And valence electrons help us to predict what types of ions form. So group 1 has one valence electron. They are okay with giving that one valence electron away, and they have a positive 1 charge. Group 2, 2 valence electrons, give 2 away, positive 2 charge. Hop to the other side, we have 17 or 7A. These guys have 7 valence electrons. They want 8, so they steal 1 electron. 6 valence electrons, steal 2, 5, steal 3. These guys in the middle, you probably have noticed them. So there are some that form different types of ions. We'll address those in the next video. For today, we're going to stick with these very predictable ions. Adding elements together. So again, our poster child for ionic bonding is sodium chloride. So that's what we're going to talk about first. So sodium, Na, he is in the first column. He has 1 valence electron. So he's going to want to give 1 electron away. He's happy to give it away. And what is the charge that forms when he does that? Giving is a good thing. So he's got a positive 1 charge. He forms a bond with chlorine. Chlorine is in the 7th group. He has 7 valence electrons, and he is trying to steal electrons from anybody that will give him 1. So he's going to see this electron just floating around, and he's going to say, "Thank you very much. I will take that electron." When chlorine takes on that electron, he will become an ion. He will become a charged particle. Stealing is a bad thing, so he's going to have a negative charge. When these two ions come together to form a chemical bond, they are going to come together by what we call electrostatic attraction. So electrostatic attraction. That is just a fancy word for positive is attracted to negative. So this positive 1 from sodium is attracted to negative 1 of chlorine, so very much like a magnet sticks together. Sodium and chlorine will come together to form a compound. So the chemical or ionic formula for sodium chloride is just NaCl. So here we see kind of the same thing. So sodium's a positive 1 ion, chlorine's a negative 1 ion. So they come together, they form sodium chloride. I have this written out on the next slide, but something that I do want to at least address here is when we write this chemical formula. So, chemical formula. When we write a chemical formula for ionic compounds, it must be electrically neutral. So positives have to balance out negatives. It cannot have an overall charge. This one works out. +1, -1, they balance each other out. But what about this one? So here we see calcium. Calcium is from group 2. It's got a +2 charge. Fluorine is from group 7. He's going to steal 1 electron and have a -1 charge. Can I simply put this together as CAF? Is that balanced or is that neutral? No. +2, -1, well, that would have a +1 charge. That cannot happen. So what do you think is going to need to happen for calcium and fluorine to come together? We're going to need more than 1 fluorine. So we've got 1 atom of calcium. So we write down that Ca at the bottom. And then this right here is called a subscript. And that subscript tells me that I'm going to need 2 atoms of fluorine in order to balance out that calcium with a +2 charge. Or another way of saying this is, for every 1 atom of calcium, he's going to need to find 2 atoms of fluorine in order to give away 2 of his electrons. So when we write the chemical formula for calcium and fluorine, we need to use that subscript of 2 to balance it out. Before we practice some more, let's talk about just some basics of ionic compounds or writing formulas. So an ionic formula is going to consist of positively and negatively charged ions. So a positive is going to be attracted to negative, and that's what holds an ionic compound together. It has to have a balanced charge. So the total number of positive charge and the total number of negative charge has to be equal to one another. So it has to be electrically neutral. And lastly, the symbol of the metal is always written first. The symbol of the nonmetal is always written second. And looking at the periodic table, that makes sense because our metals are found on the left, nonmetals are found on the right, and we typically read left to right anyway. All right, so let's do some more examples. How would magnesium and chlorine come together to form an ionic compound? So go ahead and pause the video and see if you can determine what the chemical formula for magnesium and chlorine would be. So here's the general steps. The first step is going to be to determine the charge. So step 1, determine the charge. So magnesium is found in the second group. So it's going to have 2 valence electrons. Is he going to give those electrons away, or is he going to steal electrons? He's going to give them away. So when magnesium gives away 2 electrons, he's going to have a positive 2 charge. Chlorine. Chlorine is found in group 17 or 7A. Chlorine has 7 valence electrons. To get to 8, he's going to steal 1 electron. So when he steals 1 electron, he's going to have a negative 1 charge. The second step is going to be determine how many of each atom you need. So determine the number of atoms. Okay. So for magnesium, he's got a positive 2 charge. We're just going to need 1 atom of magnesium. Chlorine, on the other hand, we're not going to be able to use just 1. If we use just 1 atom of chlorine, we'd have a positive 2 and a negative 1, and that is not balanced. That is not neutral. So how many atoms of chlorine are we going to need? We're going to need 2. So the way that we write this is we write magnesium, then we write chlorine, and to depict this 2 atoms, we write a subscript of 2. So that's the formula for magnesium and chlorine. Magnesium. We have just 1 atom of magnesium. Very often in chemistry, the number 1 is not written out. The number 1 is simply implied. So there is a subscript here next to magnesium, and the subscript is 1, depicting that we have 1 atom of magnesium. But very often, instead of writing that number 1, we just imply it in the formula. If it makes sense for your brain to put a 1 there, go ahead and do that while you're getting used to this. But 1s are typically implied. So this walks you through the exact same process. So magnesium, we need 2 chlorines for those charges to balance out. We see the +2, the -1, and then we see the correct formula here. So just a graphic, I believe from your textbook, that walks you through the same thing. See if you can write the ionic formula between magnesium and oxygen. First step, determine the charge. So magnesium is still from group 2A. It's still going to give away 2 electrons. It is still going to have a 2+ charge. Oxygen. Oxygen is from group 16 or 6A. It's got 6 valence electrons. It is going to steal 2 electrons. So it's going to have a -2 charge. To write a neutral formula, we can simply use 1 magnesium and 1 oxygen. So the +2 balances out the -2, and it is simply MgO. So that's the formula for magnesium and oxygen. So there's a few more in the slideshow for you to work through, and I have the answers. So here's lithium and nitrogen, aluminum and oxygen, calcium and sulfur. I want to work on this aluminum and oxygen one together because built in, there's a helpful hint. So the first thing I want you to do is take a minute and see if you can determine what the charge on each atom would be when they become an ion. So aluminum is in group 13 or 3A. He is actually going to give away 3 electrons. So his charge is going to be a 3+. Oxygen, we've seen already, but oxygen is in 6A, 6 valence electrons. He's going to steal 2, so he's going to have a -2 charge. +3, -2. That's a little bit more difficult, right? So you could go through this whole process of finding the least common denominator, determining how many atoms of aluminum, how many atoms of oxygen, but that's a lot of work. Or we can use this helpful hint that helps us to quickly identify how many of each we would need. So what we're going to do, very scientific here, is we're going to flippity-flop the charges. So the magnitude of the charge on aluminum is going to become the subscript on oxygen. And the magnitude of the charge on oxygen is going to become the subscript on aluminum. So we flippity-flop those numbers. When I write the chemical formula, I'm going to have aluminum, and his subscript is going to be the number 2. And when I have oxygen, the subscript on oxygen is going to be the number 3. Let's prove to ourselves that this works. So it absolutely does work, but I just want to make sure that we prove it so that we can use it. So let's look at both sides here. Aluminum. Each atom of aluminum is going to bring to the table a +3 charge. According to this rule, I need 2 atoms of aluminum to make this work. So +3 times 2 atoms means that aluminum brings a +6 to the table. Okay, so each atom brings a +3. I've got 2 atoms, +6. Let's do oxygen. Each atom of oxygen is going to bring a -2 to the table. And according to this rule, I'm going to have 3 atoms of oxygen. Okay? So -2 times 3 atoms of oxygen gives me a -6 charge. +6 from aluminum, -6 from oxygen. Boom, it's neutral. So there's our helpful hint. Flippity-flop the charges. This will work 99% of the time for you guys. So there's the 3 that I put into the slideshow. There's the 3 answers, so you can practice this. This is a skill that is absolutely vital to your success in chemistry. It is a skill that you need to get out there and practice, practice, practice. In the next video, we will talk about naming ionic compounds, and we'll come back around to these formulas as well. I hope you guys find this helpful.